So far throughout the course, we covered a large number of bugs and vulnerabilities. We focused on one bug or vulnerability at a time, and we dived deep into it, covering different scenarios, different ways to discover it, and bypass security and bypass filtering, and sometimes even different ways to display impact and to exploit it. But in a real life scenario, this is not always the case. You don't always know what the target is going to be vulnerable to. You usually have a website and you have to discover bugs or pen test it. Therefore, I decided to create the next section, and it's actually not a small section, it's pretty big, it's almost 2 hours. And in that section, I'm going to walk you through an actual real life bug hunt. So I'm going to show you how to combine everything that you learned so far throughout the whole course in order to discover bugs and vulnerabilities in a real life platform, in a real life website. I'm going to show you how I approach a target, how I get a feel on how it works and discover information about it and analyze it. And then I'm going to show you how to test it and discover bugs and vulnerabilities within it. And we're going to discover bugs in places that most people will think are secure and just ignore. And also, as I do this, I'm actually going to teach you more techniques and more methods to discover bugs and to think like a hacker or a bug hunter. And we're even going to cover new bugs that we haven't covered in the course, such as open redirect vulnerabilities. So grab a coffee, stay focused and be awake, because this section is going to be full of useful, practical information. So in the next lectures and in this section, we're going to be performing our bug hunt on this website right here, called Fast Food Hackings. This is actually a website made by a really good bug hunter. His name is Xanos, and he made it to help people learn bug hunting. So all of the bugs that are included in this website are actually inspired by real bugs that were discovered by him and by other really good bug hunters out there. So everything that you're going to see, all of the technologies used on this website are real technologies used on real websites. And you'll see that this website looks and functions exactly like a real website. And like I said, all of the bugs that we're going to be discovering actually existed in real websites at some stage. And this really good bug hunter, Xanos, actually discovered a lot of them himself. Now, as mentioned before, and as usual, before we start testing for bugs, the first thing that we usually do is use the website like a normal user, just to get familiar with the way it works, with the functionality that offers, and just to see what are the expected results, what a normal user should expect from this website. Now I'm doing all of this in the web browser that comes with Burp. So I already have my proxy, the proxy is off, I clicked on open web browser, and this is the browser that I have. And the reason why I'm doing it in this browser and not in a normal web browser, because when I'm gonna start using this website and browsing it, every single link that I click and every single resource that gets loaded in this website is still gonna go through Burp. And therefore, in the dashboard, we're gonna see a list of all of the issues that Burp think might need some attention. So these could be useful, but what's really useful is the data that you're gonna see in here in the target. So you're going to see all of the requests and all of the resources that were loaded. You're going to see the request, you're going to see the response, and you're going to be able to filter through this. For now, we don't need to worry about it, but as we go through the bug hunt, you're going to see me come here and I'm going to show you some of the features that we're going to use in here, and I'll talk more about this. But the main thing that I wanted to get across now is that I am not using a normal web browser in here. I'm actually using the web browser that comes with Burp that we can launch from the proxy window in here. So you're going to just come into this website. We're going to forget about the existence of Burp for now, and we're simply just going to browse the website and see what it does and what functionality it offers. So you can see here on the top, we have our menu. If we click on it, we're going to get the menu. None of this is clickable. None of this is clickable either. So I'm trying to click every button and just see every single feature that is available. So from here, I have nowhere to go. So we're just going to go back to the home. And then let's go ahead and check out our locations. So that's the other page or feature that is available on the website. And in here, again, we're getting the reviews on the top. We're getting the team, but these are not really clickable. We can't really go anywhere. We have a map. And we have some features. Again, nothing is clickable, so we can't really go anywhere yet. Now, as you know, once we start intercepting data with Burp, we might see more requests and more parameters and more values sent in here. But so far, there's nothing that interesting. We're just getting an idea of how the website works. So right now we have a button that says return to home, or we can click here to go to home. So we're going to click the button just to see what happens. And we're back at the home page. So we tested all of these features, but you can see also we have a booking feature in here that allows us to book a table probably. So again, let's just click it and use it and see what we should expect from it. So again, this takes us to an interesting page, book.php, and you can see there are 3 different values that are taken from us, and they will probably be sent as a post when we click in here. And that's probably sending a request to the web application in the backend to do something. So this is going to be very interesting to test later on. But again, for now, we're just testing it normally like a normal user. So I'm just putting any values in here. Put any date. I'm not really trying to break it now. I actually want it to work as expected. I'm going to click on reserve, and we get a message saying your booking submission has been received. So that kind of gives us a hint also that something was sent or submitted to the backend. So we're going to click on OK. And once we do that, there was actually something interesting happened in here. I don't know if you saw it, but there was a value that were submitted. And now we're back in here and we're getting a message saying the order is pending confirmation. We have the order ID being displayed in here as well. So lots of interesting stuff happening in here, and I can't wait to come back and test this. And you'll actually get this when you're actually pen testing or bug hunting. So we're done with this, and something that has grabbed my attention already is the fact that there is always only 2 items in here in, let's call it the main menu of the website. But if we go to the locations page, so if we go to our locations again, there is a new item in here called return home. So this only appears in the locations.php. So that's also something interesting that I would make a note of and come back to when I'm testing the locations page. So anyway, let's return to home. And let's scroll down. So we tested the booking, we tested all of these items in here in the menu, and I actually forgot to click on the login button in here to see what that does. So if we click on that, you can see we have a pop-up that first of all allows us to request an account. So if we click in here, it's actually not letting us create an account, so that's not that useful yet. And we also have a login that should allow us to log in if we have a correct username and password. So again, we're just testing it to see what happens. I'm putting wrong information and it's telling me that I am putting the wrong information, so that is fine. So now we tested everything in here. We tested the booking, we tested all of these items. The login is obviously very, very interesting, and there's a few functions that's happening in here in the request account and in the login. That's data being submitted to the web application for sure, which means that it should be tested for everything that we learned. But again, we're not in the testing phase yet. We're just getting an idea. I don't want you to get bored of this lecture, but this is very, very important to actually use the website like a normal user and use every single functionality of it. Sometimes I even come in here on these pictures and I would inspect the element and see if the picture URL in here, if it's actually the picture URL, or sometimes the pictures are loaded using parameters. So you would see something like ID is equal to 1, or maybe you see image is equal to beer.jpg instead of it being loaded like this. So even that can be very useful, and even that can expose some information. So we can see that there's a directory in here called assets. I know it seems like I'm rambling right now, but it is the hardest thing to teach you is what comes with the experience, is the mentality, how to think like an actual bug hunter or pen tester or a hacker in general. So again, coming down in here, there's nothing in here, nothing is clickable, so that's fine so far. Again, you have a slider in here that's sliding through the images. There's JavaScript responsible for loading this probably. So again, I would go ahead and inspect the element, or even just open the image in a new tab to see how it's being loaded. And we can see it's just a hard link to the image, so no values are being passed. There is no equal signs. So that's fine. If I see that, I kind of just leave it, just kind of note the directory in here. So again, we have a directory called img. So now we know there is a directory called img and there's a directory called asset. So as we go through this, you start forming some kind of a structure or an idea of what the target web application is. In many cases, each one of these pages would actually have more functions and would have more links, and I would end up opening them up in different tabs and then go and inspect every tab individually. But for this website right now, we actually have clicked on every link and we've used every single possible functionality. If the website allowed us to create a user, I would have actually created the user, logged in, and used whatever features that the user is allowed to use, again, to get an idea of what's available and what are we allowed to do, because all of that could be vulnerable. But in our case, we weren't even able to create a user. That's why I didn't create that. But at this stage, I feel like we have a really good general understanding of how this website is structured and how it works and the feature it offers. So in the next lecture, we're going to go ahead and start testing these features and try to discover bugs in them. So now that we have a good understanding on how this website works, let's go ahead and start trying to discover bugs within it. And before we even start doing that, let's start with the simplest way of discovering endpoints and possibly discovering sensitive data on the website. Because remember, if we manage to access data that we're not supposed to see, then it will be an information disclosure vulnerability. And even if it's not a vulnerability, we might be able to discover data that will help us discover other bugs. So searching for sensitive information is always a good first step. So let's go ahead and load the robots.txt file. Now keep in mind this file does not always exist, but it's worth a try. And we covered it before and we said this file contains paths that search engines should avoid and not load. And therefore these paths might be interesting to us since the website owner or creator is telling search engines to avoid. So let's try to load it. We got nothing to lose. And once we do that, as we can see, we're actually getting a file with useful information. And you can see it's saying that this allows search engines from loading admin and from loading the Go directory. So now we know there is a path that is called admin and there is a path that is called Go. So let's open up a new tab and try to load the admin path. And as you can see, we get a not found. So there's something wrong with this. But we're pretty sure that there should be something called admin. So let's try to do admin.php. And this is redirecting us now to the home page. So the path itself worked, but it probably knew that we're not admin, and that's why we were redirected in here. So this is interesting, but I'm going to keep it later on for more tests because logging into the admin would be great, but I feel like it would be easier to achieve once we discover more information about the website and have a better understanding of it. So what I would do, I would open up a text editor. I like to use Sublime. I'm going to include its link in the resources. And I'm just going to paste the path that was interesting to me. So it was admin.php for further testing. And I'm just going to add a note to myself later to say test later. You might think that this is too simple and you can remember it and you should keep it in your mind. But trust me, once you start digging deep into websites, you might start forgetting small things like this. So it's always better to take notes and actually write meaningful reasons why you're taking these notes. So I'm telling myself to test this later once I have a better understanding of the website. So let's go back and look at the robots.txt, and the next path that is interesting is the Go path. So let's go ahead and load this path. So again, we load the Go on its own, and that's probably not going to work because the admin didn't work when we loaded it like this. And as you can see, sure enough, it didn't work. So we're going to do go.php this time, and let's see if that works. And that actually works, but it's giving us an error message. It's saying invalid return URL supplied. So this error message should give us a clue that this go.php file probably takes some kind of a value, and it's some kind of a URL because it's saying invalid return URL. Now we haven't specified any return URL, so it's probably expecting us to give it that. So at this stage, there's going to be a bit of guessing. So we're going to put a question mark as usual when we want to supply information to the target. And we're going to try URL as a start. And let's just do https google.com. Hit enter and we're getting the same error. So that means the parameter name that we used in here must be incorrect because the web application is still not accepting it. So instead of this, let's go ahead and try to actually type return URL. And these are actually the things that I tried myself before I discovered the bug, and that still doesn't work. So I went ahead and actually did return underscore URL, because that's what I would name it if I was actually programming this web page. And again, it's not accepting this. So in that case, so in programming, there's a number of ways to name variables if you want to include a space in it. Some people like to use underscore, and others like to capitalize the next first letter. So instead of return URL like this, they would do return capital U and then URL. And if we do this one, perfect. As you can see, we get redirected to the website that we supplied, which was google.com. So this on its own is actually a vulnerability that is called an open redirect vulnerability. I did not dedicate a lecture to it because of how simple it is, as you can see. And since this vulnerability actually left the OWASP top 10 because it is not very common, but that doesn't mean it doesn't exist. As you can see, it exists because, like I said, all of the vulnerabilities in this website are inspired by real vulnerabilities. So the impact of this vulnerability, it's gonna allow you as a hacker to craft a URL such as this and giving it to a user that trusts target.com. So this could even be the admin of target.com, and obviously they trust their own website. So you can send it as an email or even send it to employees. And once they load target.com thinking they're going to end up on a trusted website, because this website is vulnerable to an open redirect vulnerability, once they execute or load this link, they're actually going to make a direct request to evil.com and they will end up loading evil.com. So the impact of this can be very severe because you could have malicious code running on evil.com, or you could have a clone of target.com and ask them to log in and then steal their credentials, and the list goes on. So the possibilities of this being used by malicious hackers are endless, and it can actually be very dangerous. And therefore, in a bug hunt, you will definitely be awarded for discovering an open redirect vulnerability. And in a pen test, you should even pursue this even more. So you should actually start exploiting it and target users and admins and see how far you can take this exploit to, and obviously at the end include it in your report. Now, it's very important to understand the difference between open redirect vulnerabilities and server-side request forgery. In an open redirect vulnerability, the result is the user is going to make a request to the evil website specified in the malicious URL. Whereas in an SSRF or a server-side request forgery, the target web server is going to make the request to the other server, assuming the evil server or any other kind of server. So what's happening in an open redirect vulnerability? We're sending a forged request to the target vulnerable website with a URL, and as a result, the target website is actually sending a response back to the user, telling the web browser to load the website we specified. Now I have the load here just in red because there are a number of ways where a web server can tell a web browser to load a different website. So what's causing the web browser to load the specified website is the response that is coming back from the target website as a result of the initial request that the user sends with the URL specified. Therefore, to have a better understanding of this flow and how this is working, a good idea is to come back to Burp and enable the responses. So we're going to go to options and click on intercept responses. We covered this before, so that we understand what exactly is being sent in this response that is causing the web browser to load a completely different website. So let's go back to Burp and let's go back to the interceptor. I'm going to keep it off for now because I just want to go back to the original website before I exploit it. We're going to change this to return capital URL. I'm going to copy it so I can load it easily in the future. I'm going to turn on the interceptor and we're going to hit enter to load it. And as you can see, the initial request is here. It's a GET request to the Go file. The return URL parameter is set to google.com, to what we specified. So far so good. So this is this request right here going to the server. So that is fine. We're going to forward it. And as a result, we're getting a response. This response is coming from the target website that we're exploiting. And as a result, if you look in here, you can see that it's specifying the location header. And it's setting that to the URL that we specified in our exploit, which is google.com. And for some reason, it's appending hash type is equal to 0. So we actually never specified this in our payload. We never specified that in here. But for some reason in the response, it's being appended to the specified URL. Now, because we see an equal sign, this means that this is another parameter that we can test, and therefore we should carry out more tests by submitting the type parameter to the URL in here. Now, if we stop the interceptor, you'll see that we will actually be redirected to google.com, but the hash type equals 0 is still being appended to the URL. So this is actually something that is being sent back to the user. So the user is asking for google.com, and the response, instead of it saying load google.com, it's actually saying load google.com hash type is equal to 0. So this is another parameter that we can test for other vulnerabilities, and we can manipulate just to see what impact it has on the result. So we're going to go back in here as well, turn on the interceptor, load the same URL, and instead of setting it to 0, I'm just going to set it to 1. So it's always good to make small changes instead of starting to type text and starting to test for all of the other vulnerabilities that we know, like XSS and all of that. Let's just keep it as simple as possible. Let's just try to understand what this type parameter does. And instead of its default value, which is 0, we're just going to set it to 1. I'm going to hit enter, and we're going to see the initial request. There's nothing strange about that. And here's our type parameter being appended to it. So that's good. What we're interested in is the response. So we're going to forward, and we got our response now. And this time, as you can see, the response is a bit different. So this time in the response, we actually have some JavaScript. So changing the value for the type parameter in here resulted in this change in the response. So initially, we actually had location header followed by google.com, but this time we actually have this script, and the URL that we're specifying is actually being placed in here. So whatever value we're putting in here after the URL is being put in here inside the 2 quotation marks, which is inside a script tag. So if we can break outside of this quotation mark, we will be able to execute JavaScript. But if you look closer, just for one more second, you will notice that this is specifying a href. And we covered earlier in the XSS section that inside href tags, we can actually inject JavaScript without even having to escape anything, without even having to close anything. And as I mentioned before, it's always best to try to keep our changes as small as possible, because that way we have higher chances of injecting code or exploiting vulnerabilities. So instead of trying to exit this quotation mark and then injecting code in here, I'm going to try to inject code within this because we already have a href. And we know that we can do that by typing JavaScript : followed by the JavaScript that we want to run. And in this case, it's alert2. I'm going to keep the type equals 1 because we know if we set it to 0, the method is going to be set to header, and we won't even have this script right here. So I'm keeping the type to 1 so that my code in here, the JavaScript alert, will actually be placed inside this quotation mark. And because this is inside the href, my JavaScript will hopefully be executed. So I'm actually going to drop this, and I'm going to paste the exploit that I just created, and I'm going to hit enter. And I'm going to turn off my interceptor because I want the result to go ahead. And as you can see, we have our first request, so that is fine. We're going to click on forward. And here is the response that is coming back to the browser. And as you can see, my code is being injected in here. But literally just looking at the code, we can see that this is not going to work because as you can see, we have our JavaScript in here, so that is fine and that is perfect and it should work. But the problem is we have these values being appended to it at the end, but these values are not JavaScript and therefore they will probably break my code. But let's forward it and see what happens. And as you can see, it didn't work. So again, as mentioned earlier, when we have values that are being appended to our code that we don't like, what we do is we put a semicolon to finish a JavaScript statement, because that's the way that JavaScript works, and we put 2 forward slashes to comment the rest of the code, so that anything that follows the exploit that I just added will be treated as a comment and will be ignored. So we're going to hit enter again. That's the first request. We're going to forward it. It's fine. That's our second request. And as you can see, we have this being injected in the href. This is normal JavaScript code, so it should work. And anything that comes after it, which is this part, is going to be ignored because it is preceded with the 2 forward slashes, which will set it as a comment, basically telling the browser to ignore it. So let's forward this, and perfect. As you can see, we got our alert message executed on the target. So now we have discovered a reflected XSS in this target website in the go.php file. So a lot of people would have left this once they discovered the open redirect vulnerability, because that is an actual vulnerability and it is an actual bug and you will get a bounty on it. But as you can see, if you spend a little bit more time trying to properly understand the flow and exchange of information that is happening between the client and the server, as you can see, we managed to discover a very dangerous reflected XSS. And in this case, you have actually discovered 2 bugs instead of 1. Now let's come back to the home page and start actually testing the features that we used before. As we know, all of these links will actually make us leave this page and take us to other pages, which we will test eventually. But for now, I want to stick to this page and we're going to try the login or register in here. As we did before, let's try to log in with a wrong username and password. And if we click on login, you will notice that we actually have a parameter called act in here. Now, in other cases, you might not see this parameter in here, but the fact that we are logging in means that information is being exchanged and sent to the web server. And therefore, if you don't see that in here, you should intercept the connection with burp and then analyze what's happening, analyze the data that is being sent and modify it. But in our case, we already see this. We already see act is equal to login. So we already have a value in here, which is login, that we can test for all of the vulnerabilities that we learned before. And before I do that, I'm actually just going to put something very distinctive so I can find it and see if this value that is being typed in here, if it's being reflected on the page somewhere. So we're typing in login, and let me just type test. And I'm going to copy this term because I'm going to need to search for it. And I'm going to hit enter. So as you can see, the page loads normally. There is nothing weird in the page at all. But as we know, this might be injected somewhere in the page that is not visible in here. We're going to have to look at the page source to see it. So you could either right click and view page source, or you could inspect any element and that will reveal the page source. And from here you can do Control F and then paste whatever you're looking for. Now this will only search within the code, but you can see even at the start, before the code of the page starts, before even the HTML tag, you actually have a comment in here. And in the comment, you have whatever we injected, the login test is being inserted in this part of the page. So a better way of finding this would be to right click and view page source. And if you do Control F and paste it, you will find it in here at the very top of the page. Now previously we learned we can use double forward slashes as a comment for JavaScript. We also learned that we can use a hash and double forward slashes and others for SQL when we're doing SQL injections. And in HTML, you can also add comments using this syntax right here. So this would identify the start of a comment, and this will identify the end of the comment. And everything that you see within it is actually a HTML comment. And therefore, whatever you type in here will never be considered as part of the page. So similar to everything that we learned before, when discovering bugs, we want to break out of the constraint that we are in. And currently the constraint is the fact that whatever we're typing is being placed inside a comment. So if we wanted to break out of this comment and have this text being considered as part of the page, we're just going to precede it with these characters so that it is outside of the comment and that the comment ends in here. So I'm literally just going to copy this and we're going to paste them right before the value that I am injecting. I'm going to hit enter. And perfect, as you can see now, I have my login test is actually being considered as part of the page. So now that we are able to break outside of the comment and our text being placed inside the body of the page, let's try and see if we have a HTML injection. So to do that, as we did before, we're going to be putting a HTML tag before and after our text. So I'm just using the B tag in here. And then if I hit enter, as you can see, the text is bold now. So instead of being a normal text, now it's bold and we don't see the HTML tags that I inserted. And again, if I just right click and inspect this element, you can see right now it's actually being placed inside the B tags that I added myself. And therefore, because I am able to inject HTML code in here, that means I have discovered a HTML injection, and in most bug bounty programs, you will be awarded a bounty for this. So now that we discovered the HTML injection, as mentioned earlier, we always try to see if we can escalate this to an XSS. And to do that, we're simply going to replace this with a script. And we're going to type our alert code in here. So let's say alert 2. And then finally, we're going to close it with another script. And I'm actually going to remove this last tag from here because as you can see, the web application is automatically appending the closing tag in here. And as we mentioned earlier, it is always best to do the least amount of changes and let the web application close tags for you or close the comment or just let it complete your exploit. So that's why I'm leaving the script tag open. You can obviously test with both, but that's why I'm doing it this way. So we're going to send it as is. And as you can see, we have our alert being injected in here. But if we inspect the element, you will see that we have the alert on its own and the script tags that we added are being stripped. So that tells me that this website is using some kind of a filtering that is stopping script tags from being injected in the HTML. But that's not enough to make me give up because as we saw earlier in the XSS section, there is so many ways to bypass filters, and we even covered how to use the intruder to automatically go through a large list of tags and parameters and then exploits. We covered all of that step by step, so if you don't remember how to do it, please go back and revise that lecture. But what I'm gonna try, if you wanna keep this manual, if I'm actually playing with this, I actually would try a few manual things before I go to burp, because that will send a lot of requests and cause a lot of logs, and in many cases, I'd be able to get it manually. So a very common or fun tag that we can try is the image tag, because that doesn't require closing. And within the image tag, we can actually do the source, so the src, to something that does not exist. So for example, X, and then say on error. So whenever you get an error, I want you to execute some JavaScript code. And in this case, I want you to do an alert and show me number 2. So very, very simple. We're injecting an image tag. We're giving it the source of the image to something that is wrong, that doesn't exist. And we're saying when that happens on error, I want you to execute this JavaScript code. Let's hit enter and see if this works. And as you can see, it is injecting the image and the image is not loading because, the source that I gave it is wrong, which is X. But for some reason, it's filtering or removing the on error event that we have in here because we don't see it in here. So again, we covered how to do that with burp before using a cheat sheet, how we could build it one step at a time. So inject the image first, inject the source second, and then inject different events until you see the one that passes it. But If we're playing with this manually, just quickly, just to get a feel of it, we can see that the on error is being filtered, but we can also see that the web application is appending this to our image, to our payload. So I actually don't need to close this tag. And hopefully if I don't do this, the filter will fail. So let's do it. And perfect. As you can see, we managed to get the target web application to execute the JavaScript that we specified in here. And this is why manual testing is actually superior to automation. So using intruder and all that is actually really good because it's actually a hybrid between manual testing and automation. So once you start playing with the code enough, you can actually have your intruder submitting the exploits without the closing tag because you know that your target does not need the closing tag. Another interesting feature that we should test is the booking. So let's click on book now. And we already saw how this works, but we're just going to do a quick recap. I'm going to put my name as test, my email as test@test.com. I'm going to pick some random date. So this allows us to book a table. We're going to click on reserve. You're going to get a message saying you're going to get an email if it's accepted. We're going to say thank you very much. That's great. And then we're going to be redirected to this page. So we're being redirected to confirmed.php. We're not at booking.php anymore. And again, you can see the information that we typed being populated in these input boxes. And you can see that it's just saying our booking is pending confirmation. And we can see the booking or the order ID. So this is a lot of information that can give us a lot of clues. So this tells me that something was submitted on a database and that's the order ID of it. All of these input boxes are being populated by values that we sent originally in the original form. So if we, for example, right click this and inspect the element, you will see we have an input box in here and its value is being set to test. So whatever we're putting in here is being reflected in the page somewhere. It is inside an input box, inside the value, but as we learned previously, if we manage to break out of this constraint, we're going to be able to inject HTML and JavaScript code in this page. So same goes for the email address and also same goes for the date. So even though the date is not a normal input box where you can type anything in it, the date, as you can see, if I click it, I can't type anything and I can only use it if I click in here and select an actual date. So it might seem like you can't really inject code in here, but in reality, once we intercept this with burp, we're going to be able to do anything we want. Because again, if we right click and inspect this element, you can see it's a normal input box and its value is being set to whatever value that is being set in here. So if we intercept the original request and change its value in burp to whatever we want, we're going to be able to inject normal text in here and hopefully we'll be able to inject some JavaScript. So let's go back, close this, and let's go back to the original booking page. So we're clicking on book now. We're going to turn on our interceptor and we're going to put any values. Actually, it really doesn't matter this time because we're going to be modifying it in burp. We're going to click on reserve. And as you can see, we have the post request being sent to this endpoint. You can see there is a parameter in here with a value saying no. So again, you should test this for a lot of vulnerabilities. And this is actually vulnerable to something. You can test it in your own time. But in my opinion, this is not a very common vulnerability. So I'm not going to waste time showing you what it is. But what's interesting is what we have in here in the bottom, which is the values that we set for the email, for the date, and for the username. So as we saw earlier, all of these values are being injected inside the value parameter for an input box. And therefore, to test for JavaScript injection, we're going to first of all close the value with a quote and close the input box with this sign and then add our script. And we're going to do alert 2 and we're going to finish the script. Now, ideally, you'd want to test one parameter at a time to see how the website is behaving. but I'm actually just going to send it to the 3 parameters. And I do this every now and then when I'm testing really quickly, and then I would zoom in and test every single parameter on its own. And as we saw earlier, once you get some clues, you can go ahead and use the intruder with the payloads from the cheat sheet and build it up one element at a time, or one word at a time if you really want to say that, until you discover the vulnerability. But for now, we're going to keep it simple. We're going to do it this way. We're going to click on forward. Going to click on OK, and we're going to stop intercepting it because we don't want to do that. And perfect. As you can see, we are getting our code to be executed. So we have our JavaScript code injected in the page, and therefore we have discovered a reflected XSS vulnerability. Now, if I click on OK, as you can see now, I can see the JavaScript in here is actually being placed within the input box. So that means this input is not vulnerable because the web application knows that this is just part of the input. It is not code. Same goes for this one. It's being placed within the input. It knows that this is not code. It's part of the input. But in the date, we actually don't see anything in here. The script that we pasted is not actually being displayed in here. And if we right click and inspect the element, you will see we have the date that was selected. And then because we closed the value and we opened up our own script, you can see our own script is being treated as code, as part of the page, and therefore it's being executed on the page. So there you go. The date parameter, even though it seems like you can't put any code or any text in it, once intercepted in Burp, we're able to put anything and inject anything within it. And as you can see, the programmer probably filtered these inputs thinking that they can be manipulated and thinking that this one cannot be manipulated. But as you can see, we managed to inject code in it by simply intercepting the data in Burp. Now, we're still not done with testing the booking functionality of this website, because if you paid close attention to when we were using that feature originally, you would remember that there was a lot of data being exchanged between the client and the server until we ended up at the confirmed page. And therefore, that means there is more tests to be carried out. And that's why we usually use the feature as is before we start exploiting it, so that we can see the whole normal flow. And therefore, in the future, even if we discover a bug, we know that there might be more to discover. So again, if I just go to the booking and we're going to turn on the interceptor, we're going to fill anything we want in here, just some random data, put a random date, and click on reserve booking. As you can see, this is the original request that we saw, and I told you there is a vulnerability in this, but we're going to ignore this one. And then we tested these parameters in here in the previous lecture. So we're going to ignore them this time. We're going to click on forward. We're going to click on OK. And now we have another request. So it's a GET request. It's being sent to confirmed.php, and we have a parameter called order ID, and that order ID is equal to a certain value. So this is pretty interesting because this parameter is actually in the middle of a flow. I'm actually just going to send it to the repeater real quick just to see if I send this request as is, what kind of response am I going to get? So as you can see, it seems like we're getting a full HTML page. I can click on the render in here to actually see the page that we're getting. And this seems very similar to the actual page that we were getting. So it's the final result that we were getting when it says the order is pending confirmation, and it shows us the order ID right here. So now we have a parameter and we have an equal and we have a value. So as usual, you should play with this value and try all of the vulnerabilities that we learned throughout the course. But before doing that, this value looks quite interesting. So it's random characters. It doesn't seem like it's an actual word, and obviously it's not a number. You can also see that it ends with an equal sign. And with experience, once you see something that ends with an equal sign, that is a clue that it might be encoded with an encoding that is called base64. Now, the nice thing about Burp, you can simply highlight any text you want, right click, and then you can convert that. So you can encode or decode the selected text. And as you can see, we have base64 in here. And if I'm suspecting that this text is base64, I'm actually going to click on decode to get the original value. And as you can see, the original value is an actual number. and that number corresponds to the order number. So now we understand that the confirm.php file takes a parameter called order ID that is followed by the actual order ID, but the order ID is encoded. So in this case, instead of seeing the actual number, we were seeing the encoded version of the order ID. So just by being curious and just employing this researcher or bug hunter mentality, before you even try to discover all of the vulnerabilities that we learned before, and before you start trying to send some payloads in here, let's see what happens if we simply request a different order ID. So instead of this order ID, so this is 69, let's see if we can load the order that was submitted before us. So 68. I'm gonna click on send, and as you can see, this doesn't work. So this whole thing broke and we did not get a useful response. But that's probably because the web application is expecting the order ID to be encoded in base 64. Therefore, I'm gonna select my order ID. I'm gonna right click, convert selection again, base 64, and this time we're going to encode it. And as you can see now, the text actually seems similar to the original one that we had, and it also ends with an equal sign, because that's what I said before. When you see text that ends with an equal sign, it's a hint that it might be encoded in base 64. So let's send it like this, and it looks like it worked. As you can see, we're able to access an order that was submitted by someone else. So in this case, someone that is named Deidre, and we can see her email in here. And therefore, we're actually able to load orders that were submitted by another user, which we're not supposed to see. And therefore, this is an example of a broken access control. And as mentioned before, this is a very, very common bug. Over 94% of websites are vulnerable to it. So the fact that we discovered it in here is not surprising at all. And that's why in pretty much any bug bounty program that I've seen before, you will actually be rewarded a bounty for discovering such bugs, because we're able to load data that belongs to other users. Another thing that should draw your attention is the fact that we're seeing the order ID in here. So I want to see if this value can be manipulated by changing the value in here. So let me just type some normal text like test, and then we're going to encode it to base 64, and we're going to send it, and the website fails to load. So this tells me that this order ID that we're seeing in here is being read from somewhere else. And therefore, if I put any text in here, including JavaScript or HTML text, it's simply just going to break the application. It's not actually going to be displayed in here. And therefore, we can't find a HTML injection or an XSS vulnerability in here. But as you saw earlier, we do have a broken access control vulnerability in which you will definitely be awarded a bounty for. So far, we tested every feature within the homepage, from the booking to the login page, and there's no other features below. So the next thing that we're gonna do is test the menu and the locations pages. So starting with the menu page, we're just gonna load it normally. And as you can see, it just loads a normal menu page with the menu and with some categories on the top. None of this is clickable, and we don't have any parameters in here to inject and play with. So we're just going to turn on our proxy and load it again to see if we can find anything interesting in Burp. So far, nothing is that interesting, so we're just going to continue forwarding this. And these are just CSS files, so they're styling files that are loading a certain font from a host that is called fonts.googleapi.com. So it's nothing to do with our target. This is very important. You need to make sure that you do not test stuff that is outside of the scope. So our scope is this website. So anything that is outside of this website should not be tested. So that's why we're ignoring all of this. And here we go, we have another request that is made to our host. Again, nothing that interesting in here, so we're gonna forward. And now we actually have something interesting. So we have a request in here that is being made to some kind of an API to a file called loader.php. We have a parameter name f, and the value that is sent to it seems like a file name. So it starts with a /, which we know from the directory traversal vulnerabilities. A / means we're starting to specify a file path starting at the base directory. and we have a file name that is called reviews.php. So this is a very, very interesting request, and therefore I'm going to right click and send it to my repeater. And in here, I'm just going to send it as is just to see the normal result that I would get. And if I render this result, as you can see, we're actually going to get reviews because it's requesting reviews.php, and we have the review content and the name of the person that submitted the review. So this is really, really cool. But what I would do at this stage, once I see this is a very strong clue that I should test for directory traversal or local file inclusion vulnerabilities. And as we know, the way we do this is by doing ... go back as many files as we want, and then test for a file that exists by default on the target, like etc password. Now I covered this in details in a full section, that's why I'm doing it very quickly in here. If you don't understand what I'm doing, then please go back and revise that lecture or that section. So we're gonna send it, and as you can see, we get nothing. And as you saw in the previous section when I covered these vulnerabilities, just because you got nothing from your first request does not mean you should give up. There are so many ways to bypass security and to actually get this to work, so you should really test everything that I showed you before, and you should go ahead and use the intruder again as I showed you before. But once you do all of that, you will notice that this parameter is actually not vulnerable to a local file inclusion or a directory traversal vulnerability. Therefore, in that case, I'm just going to go back to its original form and just think what is being done in here. So right now, this loader.php is requesting another file that is called reviews.php. So maybe it's implemented properly so that I can't actually load any files outside of my web root. But from my notes that I took earlier, I have something saying I should test later the admin.php page. Because when we loaded this, we didn't get an error, we simply just got redirected. So let's see if I load this page from here, if it's actually gonna load for me. So let's just go ahead and type admin.php and send it. And as you can see, I get nothing. So if you remember in the robots.txt file, it actually was called admin and not admin.php anyway. So let's try to load the admin path as is. And once we do that, this time we're actually not getting redirected, but we're getting a page saying we're not allowed to view it. So that's really, really good. So at this stage, we're getting closer, we're getting better error messages, and at least instead of just getting nothing, we're getting an error message telling us we're not allowed to load this page, but we know that there is a page that is called admin, and I can access it using this URL. So again, just being curious and implementing that bug hunter or researcher or hacker mentality, I want to know, how is this page knowing that I am not the admin and I'm not allowed to see this page? It's not really asking me to put a username and a password, but somehow it's able to know that I do not have permissions to view this page. So I'm going to try to load it from a browser instead of loading it from the repeater in here. So I have my proxy on. I'm just going to turn it off to let the flow through. I'm going to turn it on again. I'm going to go back to my website here, and I'm going to paste the path that we just copied. So we're simply loading the same file, loader.php, and we're trying to go to the /admin. I'm going to hit enter, and that's going to be intercepted in here. So that is fine. We're going to forward. And as you can see, this time there is another request that is being sent to the admin.php this time. So initially the request was being sent to loader.php /admin, as you can see in here. But right now, after we sent that request, we have another request being sent to the admin.php. And this request is sending a parameter called add token, and the value of this is blank. So now if I forward this and keep forwarding the irrelevant requests, you will notice I'm gonna get the same error message that I got in my repeater, which is saying I am not allowed to view this page. So my hunch tells me that if I send this again, and let me show you, this add token value that is being set to nothing needs to be set to some kind of a password or a token that is supposed to give me access to the admin. So if I manage to find a token or a value to send in here, I will actually be able to access the admin page. So in this case, I would actually again take this and save it in my notes in here. So this is actually related to the same thing, to the admin page.php. And this time we know that if we give it an add token in here, we might actually be able to log in as admin. Now we don't know where we're gonna find this. So usually I would go and continue pen testing the website until I get more clues about the add token. But before I do that, I would go ahead and run a quick search to see if the add token is mentioned anywhere within the website, within the JavaScript or within some hidden elements that load on the website. And to do that, I'm simply gonna copy this text, add token, and I'm gonna go back. We're gonna go to the target tab. So this is what I said we're gonna use in the future. And as you can see, this target tab has mapped the website. So it actually has mapped every single link that we clicked and every request that we sent. So it basically analyzes every request and every response that was proxied through Burp. And that's why it's very, very useful, because I can use the filter functionality in here to search within all of the data that was exchanged between my browser and the web server. So I can search in here for the add token because I'm interested to see if this was mentioned anywhere in the code and if I can find any clues for that. Now the filter feature in here is only available for the pro version of Burp, but it's actually very, very useful. If you are serious about becoming a bug hunter, then I highly recommend getting the pro version. And if you're working as a pen tester or if you're working for a company, all you have to do is simply ask your company to purchase a license and they will do it without hesitation, because this program is very, very useful and it will really enhance your bug hunting capabilities. So we're telling it that we want to search for add token and we want to search in these files. So you can select more files if you want, but we're keeping it the way it is in here. We're keeping all these extensions the way they are, and we're going to click on apply. And as you can see, we have all of the requests and the files that contained add token. And this is just the request that we are playing with right now. And this is the add token. So there's nothing interesting in here. This is the loader.php file. So again, if I am looking for it in the request, I can put it in here and look for it, and there's 0 matches. If I want to look for it in the response, you can see we have 1 response in here. And again, nothing that's useful in here. It's just in the script. It's mentioned in here. And the third occurrence in here is in a file called script.bin.js. So it's a JavaScript file. And as you can see, we have a 1 match in here. And let's look at the match. And as you can see, this, even though we don't know what JavaScript is, you could guess that var means variable. So they're defining a variable that is called add token. And you can actually just see the value in here as a string enclosed by 2 quotation marks. So that is very, very interesting. And even if you don't know JavaScript, your intuition should tell you, I should send this in my request and see if that's actually going to allow me to get access. So let's go back to my proxy, and I'm actually going to stop intercepting just to let this flow through, just in case there is an expiry on it. We're going to turn on the interceptor again, send it, and the first request is okay. It's just asking for the admin, so we're going to let it go the way it is. And these are just requests outside of our scope. And we're going to paste the add token in here, and I'm actually going to copy all of this. I'm going to stop the interceptor. And I'm going to paste that request in here along with the add token. Make sure everything is correct. Hit enter. And perfect. As you can see right now, you're only getting a message that is saying there used to be a flag here. But basically this means in a real life scenario or in a bug hunt, you would have been able to access an admin panel or some kind of admin resources that normal users are not supposed to access. The term that just means that there used to be a flag in here. This is a normal practice that is done in capture the flag competitions and even in job interviews if you apply for pen testing jobs where in order to test your skills, they would put flags in certain locations within the application and you have to test them. So the fact that we're seeing that there used to be a flag in here means that we actually managed to gain access to this panel, and in a real life scenario, you would have been able to discover a broken access control vulnerability where you are able to access functions that normal users should not have. In this lecture, we're going to continue testing the loader.php file with the f parameter, and we're going to see if we can discover any other vulnerabilities or if it can point us towards other bugs or vulnerabilities. So far we know that we can, originally this used to say reviews.php and it just loaded the reviews, and then we saw by sending the admin we were able to be pointed in a direction where we were able to log in as admin. Now, again, as a bug hunter or as a hacker, you should ask yourself, what other values can I set the f in here to? You can simply use the intruder, as I showed you earlier, and set the s's in here after the f and test for a large number of words and just have it automatically send these words for you. But before doing that and before you start guessing, let's see if the code and the data used in the target website can point us to the values that we can use in here. And to do that, again, we're going to use the target and we're going to use the filter functionality in here, similar to what we did in the previous lecture. And instead of looking for add token, we're simply going to look for f is equal to whatever. So we're going to see if any of the code that is used on the website can give us any clues of what values we can set the f to. So we're going to click on apply, and as you can see, we're already getting a lot of results, so you're going to have to go through them one by one. So in here you can see that f is equal, we have one match and it's equal to admin, and that's something we've already tested, so that's not interesting. And here again we have two matches, that's the first one and that's the second one, just the admin. And similar in here, this is actually looking for the add token. So if we look for f is equal, these are just hrefs. So they're just normal links on the website that are not really pointing us towards any endpoints or any useful values. Going to the next one, the custom script.javascript, which sounds like it's promising because it's some JavaScript in there. If we look for the first occurrence, you can see it's just pointing us to some code. We'll get back to this later anyway. So we're going to look to the second one. And again, it's just a href giving us some code. So it's nothing useful again. So we're going to go to the next one. Hopefully this one is promising. So again, we're not really getting anything useful in here until we get to this line. And this is actually very, very useful. Because as you can see, it's actually saying f is equal to / generate credentials. So if we manage to send this and if this actually works, we might be able to generate some kind of credentials to log into the website. So we're going to copy this and we're going to go back to our repeater, and instead of admin, we're going to say generate credentials. We're going to send it. And perfect, as you can see, we actually got a response with a username and a password. So I can actually just copy this and paste it in my notes. So data found. And we're going to be able to log into this website, hopefully, with this username and this password. So as you can see, by simply just paying more attention to our parameters and searching through all of the data that we have, we were able to get a username and a password that'll allow us to log into this website. And then once we log in, that's obviously going to expose more features, and hopefully we will be able to discover even more bugs and vulnerabilities in this website. So now that we have a username and a password, we can actually go ahead and log in. And from there, we're going to be able to access more features, more pages, and therefore, hopefully, we're going to be able to discover more bugs and vulnerabilities. Because, as you know, the more features we have, the bigger the scope it is, and the more likely it is to be vulnerable. So we're simply just going to go to the home page. We're going to click on login, and I'm going to copy the username. And we're going to get the password from here. And we're going to click on login. Now, obviously, you should test the values sent in the login form, but I've done that myself and I know that they're not vulnerable, so that's why I'm not wasting your time with it. And once we're logged in, as you can see, we are getting access to our profile page. Now this page is very zoomed in, that's why it looks a bit weird. But as you can see, it's giving us the name, the role, and some bio about this person who is a big fan of pizza. And we also have the interests in here. So that's pretty cool. And we have a new page now. It's called yourprofile.php. Nothing being sent to it, so there isn't much to be tested, and none of this is clickable. So as usual, when we don't know what to test, when there's nothing to test, we turn on the interceptor and we load the page again. So let's look at the proxy. And as you can see, we have the request to the Your Profile page with no interesting data being sent to it. So we're just going to forward it. And another request to the same page with nothing interesting. So again, we're going to forward this one. Some requests to irrelevant websites that is outside the scope. So we're forwarding these as well. And finally, just before the page loads, you can see we actually have an interesting request with an ID and a data parameter. So the data parameter is set to bio and the ID is set to a very long ID. So this is very interesting. We're going to right click and send it to the repeater for further testing as usual. And in the repeater, we're going to send the request as is. And as you can see, as a result, you're getting the bio of this person. So you're getting the bio that is relevant to the user that has this ID. Now, as you can see, the ID is very, very long. So naturally, you're going to think that there is nothing I can get out of this. And all you're going to do is basically test the values in here and here for all of the vulnerabilities that we know, from SQL injection to XSS and so on. But you should also try to just load normal IDs. Even though this ID is really, really long, the web application might still respond to requests of normal IDs that are not this long. So for example, let's try to load the bio for a user ID 1. Let's send it. And perfect. As you can see, we actually got the bio for a completely different user. Test account for Zano. Now we can try to set this to 0, see if we can get anything for the admin, because the admin sometimes have 0, and this is saying this user account doesn't exist. If we try 2, it's giving us the bio for account 2. So as you can see now, we're actually able to load data that belong to other users, and therefore we have discovered a broken access control vulnerability. So we discovered an insecure direct object reference or an IDOR vulnerability. So far, we tested every single visible feature within this website and we clicked on every single visible button. And as a result, we discovered a lot of bugs and vulnerabilities. We also discovered bugs and vulnerabilities in hidden features and in hidden code, and we were able to do that by relying on the filter functionality in here. So we went to the target, we went to the filter, and based on some clues that we saw on the website, we searched for certain parameters, such as the F parameter in here, because we got a clue for it while we were testing one of the pages, while we were testing the menu page. And as a result, we discovered other values that we can send to this parameter, such as the value that we sent in here to generate credentials, which allowed us to get the credentials. And then we logged into the admin, and then we were able to test even more features. I'm saying all of this because I'm trying to tell you that testing every single visible feature and pressing every single button is not enough to properly cover the web application. Because as you can see, we were able to discover bugs and vulnerabilities in hidden code and in hidden features. Therefore, usually at the end of the pen test or the bug hunt, I would dedicate some time and put some effort into trying to discover hidden features and hidden parameters and then test them and hopefully discover more bugs and vulnerabilities. So in this lecture, I'm going to show you how to use regular expressions in order to find more endpoints in this website that we were not able to find by simply clicking on the buttons, so that hopefully we can discover bugs and vulnerabilities in these endpoints. We're going to do this using regular expressions, like I said, and basically using regular expressions, we can tell Burp to search for specific patterns within all of the files that it has intercepted. So within all of the JavaScript and within all of the application files that were exchanged between the browser and the web server. And as a result, hopefully, we will be able to find endpoints. Now, regular expressions are used all over the industry, not even in cybersecurity only. It's used in programming and it's used in so many other applications because they're very powerful, because they allow us to specify a pattern and then get the program to match a string based on that. I know it all sounds confusing, but let me show you how to use them in real life to discover endpoints, and you'll see how easy it is. So basically, the goal is I want to see any other parameters that I can give values to and manipulate in order to discover bugs and vulnerabilities. So we learned before, even at the start of the course, we always look for something like a question mark, followed by some text, followed by an equal sign. So what I want to do basically, I want to tell Burp to find any sequence of characters that matches this pattern. I want a question mark followed by some text in here, so let's just say XXXXX, and followed by an equal sign. I want it to search all of the files that it intercepted in the target website, and if it finds any of them, I want it to show it to me so that I can test these parameters for more bugs and vulnerabilities. And we can do that very easily using regular expressions. So first of all, I'm just going to show you, we're going to go to the target, we're going to click on the filter, and we're going to enable the regex text box in here. So we're telling Burp, I'm not going to search for a normal text, I'm going to search for regex. And like I said, we want it to start with a question mark. So we're going to put a question mark. And then we want to match as many characters as possible, followed by an equal sign. And here's where you're going to see the power of regex. We're going to tell Burp to match as many characters as possible between a question mark and between an equal sign by basically saying dot star. So dot means that I want to match any type of character, and star means any number of characters. So if I just put one dot, it's going to match only one character, but I don't care how many characters are there, as long as they are enclosed between a question mark and an equal sign. Now, as you can see, in regex, you can use dots and stars, so you can use special characters to indicate different meanings. So the question mark can actually be used to stop matching before the end of the line. So to stop matching once this pattern is found. But we actually don't want to say that in here. We want this question mark to be part of the regular expression, like we said, because we're looking for a question mark followed by a series of characters followed by an equal. And therefore, to tell Burp to not treat this question mark as a special character and to actually treat it as part of the pattern, I'm going to have to put a backward slash before it. And finally, we want to tell Burp to not continue matching, because remember, it's actually going to search for this in code and there could be a lot of lines of code. So I want it to stop looking for this pattern once this pattern is satisfied. I don't want it to continue matching all the way up to the end of the line. And that's why I'm actually going to use a question mark in here. So basically, just to make this simpler, we're using a dot star to say I want to search for any sequence of characters, for any pattern that matches this, as long as it starts with a question mark and ends with an equal sign, which is exactly what we want when we are looking for parameters that we can manipulate to discover bugs. And then we're using the backward slash to say this question mark should not be treated as a special character. It's actually part of the pattern. And we're actually using a special character as a question mark in here to say that I want to stop as soon as this pattern is discovered. I don't want you to continue matching the whole line that contains this pattern. Then you can modify the settings in here if you want to match any other files like CSS files, styling files, and so on. But I'm happy with what I have in here. And once you're happy, we're going to click on apply. And perfect, that should have filtered what I'm looking for. So as you can see, we have all of the files that contain what I'm looking for right now. And if I click on any of them, we have the request and the response, and we can actually use the same regex to search for parameters within the request and the response. So at this stage, I would actually go through these one by one. So you can already see the generate credentials. You can already see the admin. If we go to the profile, for example, and search for the same pattern, you can see we're only matching the pattern that we're looking for. So we're only matching a question mark followed by something followed by an equal. But these are at Google API, so it's outside of the scope. It's not actually part of my target. So we're going to be skipping these because they're outside of our scope. And then eventually you're actually going to get to some interesting stuff. So we actually tested this before, the ID parameter, and it was actually vulnerable to an IDOR. And then if you continue, you might even find more interesting stuff, but there isn't in this file. So at this stage, I would actually go ahead and move on to the next file and analyze what's in it. Now, I'm not going to waste your time going through all of them because we've actually tested a lot of these. So for example, you have the ACT login in here that we discovered an XSS in it as well. But I'm going to go straight to the menu because this page actually contains a parameter that we have not tested. So again, looking in the response, we're going to click on next, and we have some stuff that is outside of our scope. So I'm going to just skip them. Right here, we're matching a pattern where we have a class. So this is just normal HTML markup. It's nothing to test for us. So we're looking for parameters and values. So that's why we're skipping these. And perfect. Right here, we have an actual parameter that we have not tested yet. So this parameter is in the book.php page, and the parameter name is promo code. And currently, as default, it is taking a value of UK only, but obviously, as usual, we're going to be manipulating this to test for all of the bugs and vulnerabilities that we learned so far. And we're going to do that in the next lecture because the point of this lecture was actually to introduce you to regular expressions and how to use them within Burp to discover hidden parameters and hidden endpoints. Now that we discovered a new parameter in the book.php page, you should go ahead and test it for all of the bugs and vulnerabilities that you learned so far. Now, I'm not going to waste your time doing that because I know it is vulnerable to an XSS, so I'm only going to show you how I would test it for an XSS. First of all, as usual, let's just go ahead and send a request to this using our browser. So we're just going to paste it in here as is. We're not really modifying anything. And I'm just going to copy it so I can play with it later on. And if we send it, as you can see, you're going to be redirected to the book.php page, and it doesn't look like anything has changed within the page. But as you know, when we're testing for XSS vulnerabilities, we want to see if the input we're typing is being used anywhere within the page, because if it is, we're going to see if we can have it treated as HTML code, and in that case we have a HTML injection, and then we're going to see if we can get the page to execute it as JavaScript, and in that case we will have an XSS vulnerability. So right now it said UK only, and what I'm going to do, I'm just going to send it again, and I'm going to add some more characters to it so I know it's unique to me. So it's UK only test, and we're going to send it. And again, we're being redirected to this page, and we don't really see it in here anywhere, but as usual, we should look more thoroughly. So we're going to open up the source, and we're going to look for UK only. And as you can see, it's not being used anywhere within the page because this is the source code of the page, and we can't actually see the value that we injected being reflected anywhere within the page. So that is a bad indication. That usually means that this page is not vulnerable. But we know that this input is actually being used in the source code of the menu page. So let's go ahead to the menu page and see if what we injected in here, which was UK only test, if it's being injected now in the HTML code of the menu page. Because that's the page that we actually originally found this parameter along with its value, which is UK only. So let's go ahead to the menu page and let's view its source. And let's look for UK only test. And perfect, as you can see, it's actually being matched at the bottom of the page right here. And this is actually amazing because the value that we sent to the promo code parameter is actually being stored in the menu page. So if we manage to discover an XSS vulnerability, it's going to be a stored XSS vulnerability that will be executed to anybody that loads the menu.php page. And to make this even better, you can see the value that we used for the promo code is being used in here, which is inside a script tag already. So as you know, usually when we want to exploit an XSS, we usually type our code between script tags. But right now, some of that work is already done for us because what we're injecting is already being placed inside a script tag, so it's already inside JavaScript code. The only problem is it's being enclosed between two quotations and it's being assigned to a variable. So whatever we type in here is only going to be treated like a normal text or normal string. It's not actually being treated as part of the code. But we covered numerous methods of breaking out of quotations before and bypassing such limitations, so you're going to have to play with them and see how you can break it. Now this one is a little bit unique, and that's why I'm actually going to walk you through it step by step. So let's copy this to a text editor just to show you how I go about this, and then we will inject it through the promo code parameter. So let's make this just UK only. So we're bringing it back to what it was originally. And as you know, the first thing that we need to do is to break out of these two quotation marks so that we can inject code. And that's why in our UK only, we're going to add our own quotation mark. And then we're going to add a semicolon to end the statement, because as you know in JavaScript and as we covered before, each statement needs to end in a semicolon. So that ends all of the statement right here. And then we can start injecting our code. So we're going to do alert to, and then we're going to put a semicolon as well to end our code. And finally, we have these two characters that will actually break our code because right now they are irrelevant. And that's why in our injection, we're also going to add 2 forward slashes to comment out the characters that come after it so that the browser ignores them and does not execute them as part of the code. So the browser is going to have this original statement, which is valid, and then it's going to have another statement, which is the one that we are injecting, which is also valid. So hopefully, if there is no security used and there is no filters, this payload right here should allow me to execute the alert code in here, and therefore I would have a stored XSS in the menu page. So let's go ahead and test this out. We're going to go to book.php. Promo code is equal to the payload that I just copied. We're going to hit enter, and that's fine. We get redirected. We know that it's actually not showing up in here. It's going to show up in the menu. So we're going to have to go to the menu page. And if everything is fine, our code should be executed now, but it's not getting executed. So we know something went wrong. So let's refresh the source code of the menu. And if we look in here at the bottom, you can see that the UK only is being injected as is, and the single quote that we're injecting is actually closing the original single quote. So that's not filtered, and that's perfect. But the problem is the alert got filtered. We don't have an alert in here. And also the double forward slashes were actually replaced with double backward slashes, and therefore they broke the code. And also these characters right here also broke the code, and that's why our injection did not work. So we have two problems. First of all, we can't use comments in here. The double slashes are being filtered, and also the alert is being filtered. Now you can try to use different types of comments, but I've tested it, and again, none of them is going to work. Therefore, instead of using comments, we're actually going to try to complete this code. We're going to try to write some JavaScript code in here that will complete these two characters so that they do not break my code and so that I will not need to use a comment. So simply what I'm going to do, I'm just going to say I'm going to create a variable and I'm going to call it x, and I'm going to say x is equal to quote a, and this way when the program adds the single quote and the semicolon here at the end, it will complete the code that I just wrote here myself, and therefore this statement is not broken anymore, and this is going to work without the need to comment out the rest of the statement. Now, the other problem that I have with the page is the fact that alert is actually being filtered. So we can use a trick that we actually covered in the directory traversal vulnerability section. And what we did in that section is the ... forward were being filtered, and instead we doubled it. So whenever the ... forward is filtered, we still have a ... forward. So what we can do, we can write another alert inside the big alert, and then the small alert is going to be filtered. And when that is removed, the result is going to be a normal alert. So all I'm going to do right here is basically write another alert in here. And this code right now, this payload, hopefully will work because we know this single quote will close this single quote. This semicolon will make all of the statement valid. And then I have a double alert. One of them is going to be removed. So hopefully I will have an alert. The 2 is not being filtered. The semicolon will make the statement valid. And then I'm just creating a dummy statement in here in which I am creating a variable with a value, but I'm not closing the quote because I know the web application is going to add the single quote and it's going to add a semicolon. And this way, this statement is going to be valid and it's not going to break my code. And hopefully everything is going to work as expected. So let's go back to the booking page. And we're going to do promo code like we did before. And we're going to paste my payload. We're going to hit enter. That'll take us back to the book, so that is fine. But we know the code is being injected in the menu. So let's refresh this. And perfect. As you can see, my JavaScript code is getting executed and displaying the alert message that is simply saying number 2. This means that we managed to inject JavaScript code in the menu page through the booking page, but this is always going to be here. So this is going to be a stored XSS vulnerability because anybody that is going to load this page will have that JavaScript code executed on their page, and therefore this is a very, very dangerous bug or vulnerability that you're going to cash out some nice bounty on if it is discovered in a big website. And just quickly, if we refresh in here to look at the code, as you can see, we have my payload in here. So the UK only, the single quote that we used is complete in the UK only. We have the alert now looking normal instead of it looking weird like this because the internal one got removed, and we have one alert in here. Semicolon finishes it, and then I have my dummy start of the statement that is not finished, but it's being finished in here by the web application, making all of this statement a valid statement and therefore executing my alert code. As mentioned previously, testing every single visible functionality and pressing every visible button does not guarantee that you covered everything and you tested everything. And we saw how we could actually analyze the code in here and use regex to actually discover endpoints that we never seen before that are buried and hidden within the code. So in this lecture, I want to continue on that idea of trying to discover hidden features and hopefully hidden endpoints and parameters so that we can test them and hopefully discover more bugs. To do that in this lecture, we're actually going to rely on a Chrome extension called LazySec. There's another one called Unhide. There's actually a lot of these extensions. And basically, once you have it installed, and installing it is very easy, you just click on Add to Chrome. You will have it in here. And once you have it in here, you can go to the target website and click it. And hopefully, it'll display some useful elements or useful links or useful input boxes that you can test. And hopefully, they're vulnerable and therefore help you discover a bug. So let's have a quick example here in the homepage. We're gonna click on the extension in here, and it's asking you what exactly do you want to display. We're gonna say I want you to show me all of the hidden elements. So we're clicking on all, and we're gonna say show hidden elements. And at first glance, it doesn't seem like it actually displayed any hidden elements. But if you click on the login, you'll actually see that it's actually highlighting the hidden elements for us in red right here. So there are 2 new elements that we never seen before, and we actually saw this one before when we clicked on request account, but we never saw this element before. And this is actually a link. So if you hover over it, it is a link. but if you click it, you're not going to go anywhere. But still very interesting because this was hidden, so it must be hidden for a reason. And therefore, I'm going to right click it and inspect it so that I can analyze this further and see what's the point of this button and hopefully understand what it's supposed to do and then maybe discover a bug in it. Now we can see that this is a link because it's using an A tag with a href, which is usually what specifies the link, but you can see that there is not a valid link in here. You can also see that there is an ID, and this is the value of the ID. Now IDs are usually used in HTML in order to identify an element, hence the name, and then JavaScript a lot of the time would manipulate this element using its ID. So once you see an ID, it's actually worth a good try to go back to Burp and look within the JavaScript files that you have in here and see if there's any reference to this ID. Because normal HTML could contain JavaScript, and see if there is any reference to this element. And that's what we're gonna do. But before doing that, I actually usually still just give it a go in here, put a question mark, put the ID, and then try a few things. So try to, because it's saying redirect URL, I'm gonna just try to redirect it to Google. So we're gonna just do google.com. And you will notice that that doesn't work. And I might actually play with this a little bit, maybe do your redirect underscore URL and try a few things, but you will notice none of that is gonna work. I'm only doing this in here just to show you how I would go about it, even though it's failing. But like I said, the fact that you see an ID in here, it is more likely that you'll actually find a reference to it if you go ahead and search in the target and in the filter in here. So this time we're not searching for a regex anymore, we're searching for a normal text. That's why we're gonna untick this box, and then I'm gonna paste what I'm searching for, which is redirect URL, and I'm gonna click on apply. And once we do that, as you can see, it's gonna list all of the files that contain the redirect URL. And like I said, it's very likely that it's being used in some JavaScript files. So the .js in here, it means it's a JavaScript file because programmers like to actually manipulate elements using their ID. So the fact that this has an ID gives me a hint that it's actually being accessed and manipulated somewhere using JavaScript code. So anyway, we have the file in here and we can actually search for what we're looking for, which is the redirect URL. And we actually have it in here. And you can see that the redirect URL is actually equal to something that is called url_params.get. Now I know what this is, but assuming you saw this for the first time and you don't know what this is, all you have to do is simply copy it, go to Google and search for it. And you can see the first result without even viewing it is actually useful. It's telling you that the .get method in the URL search param, which is what we have in here, gives you the first value associated with the given parameter. And the given parameter in this case is from. So basically, this is a way for JavaScript to get values sent using a parameter called from. So now we know that this page right here takes a parameter that is called from. So let's go ahead and test it. Let's just go back in here. And let's set the from parameter this time to google.com. Now you can set it to anything else you want, but we're just going to leave it at Google. We're going to send it. And right now, if we click on login again, you can see that the element is visible by itself. We didn't actually have to unhide it, but you can always unhide it using the same way. And we're just going to inspect it to see what happened to this element, because we know that it's being manipulated using this JavaScript, using the from. We sent the from. And as you can see now, the value of the href has changed. It used to be a hash, but now it actually has the value of the input that we placed in here. So right now, if we click on this link, we will actually go to the value that was in the href, which is google.com. And this means that we have discovered an open redirect vulnerability because we managed to get this website to take the user to another website that they're not supposed to go to. And this way we can actually inject a malicious website in here that contains malicious code, or a cloned website to this website that will ask the user to log in, and then we'll be able to steal their information, and the list goes on. So this is a very valid bug, like we said, and you will definitely get a bounty for discovering it. Also, you should keep in mind, whatever you're typing in here is being injected in the href. And as we said before, you can actually inject JavaScript code directly into the href without having to escape this, without even having to complete this element. So all we have to do is type JavaScript followed by the JavaScript that we want to run. And we're just going to do a simple alert. We're going to say 3 this time. We're going to hit enter and let's click on login. Click the link, and sure enough, our JavaScript code gets executed. So now we actually discovered 2 bugs. We discovered an open redirect and a reflected XSS vulnerabilities, and you should actually get bounties for both of these bugs. And we managed to do all of this using a hidden element that we never seen before, and we were only able to see it by relying on an extension similar to this one right here that will display hidden elements for us. We did a bit of research based on everything that we learned so far, and as you can see, we ended up discovering 2 more bugs in the target website. In the last lecture, we discovered that the homepage takes a parameter that is called from, and we discovered that that parameter is vulnerable to an open redirect and to an XSS vulnerability. We can also see the next line in the code is identical to the previous line, and it also uses the same method that we spoke about, which is the get method for the URL params, but the value this time is type. So similar to the way that we concluded that this page takes a parameter that is called from based on the value that we have in here, we can also conclude the same, that this page also takes a parameter that is called type. Now, because the name in here is not very meaningful, we can just continue reading the code and see if it can give us any hints. Again, I'm assuming you know nothing about JavaScript, and I'm actually not a JavaScript developer myself. I just know a bit to get by. We're just going to read it step by step and see what we understand. So we can see that there is an if statement, and it's saying if the redirect URL, so that is what we set in the from, if it is set to null, then this code is going to be executed, which is nothing. Else, so that's our code, this is what we are executing because we are setting the from to a value. So in that case, it's going to check if the redirect type is 1. And the redirect type is defined in here, so its value is taken from the type parameter that we can set in here. So we know now if we set its value to 1, then this piece of code is going to be executed. So before we understand what this piece of code does, let's just go ahead, and we are already using the from and we're already putting something in the from. So let's just do test, but we're going to add an ampersand and we're going to set the type. And we're going to set it to 1 because we know from here, if we set it to 1, this piece of code will be executed. Now we don't know what this piece of code does, and therefore we're going to simply copy this code, window.location.href, and simply go to Google and look it up. And again, the first result is actually really good. You don't even need to click it to understand what it does. It's telling you the window.location.href returns the URL of the current page. So right here, this statement is trying to set the location of the current page. So this is really good because if we can manipulate this, we might be able to change the location of the current page and therefore get an open redirect. So right here, we're saying the location of the current page is equal to the get hash value of whatever value that we have in here. And again, assuming we don't know what this is, we're going to copy it and we're going to paste it in Google. And as you can see, we're not getting any good results. So I'm simply going to say JavaScript. And as you can see, again, the first result seems to be useful. And it seems like this is a common way of getting the value that comes after the hash sign. So based on this, I can make the educated guess that I can use this as a parameter, but instead of an ampersand, I'm going to have to put a hash before it, followed by this value, followed by the value that I want to send. So let me show you what I mean. We are setting the from to something, we're setting the type to 1, and we usually use the ampersand to add 2 parameters together. But this right here is not a parameter because as we saw earlier, This is the way to extract parameters from the request, but right here, this is not a way of extracting parameters. This gets you whatever value that is inputted after the hash. So we're gonna put a hash, and then we're gonna put the value that we have in here, which is redir, and we're gonna make that equal to a website because we already looked up what this does, and we saw that this gets the location of the current page. So hopefully whatever website I'm gonna put after the redir after here is actually gonna be set to this value right here, and therefore the user will be redirected to that page. So let's go ahead and test that theory. We're gonna set it to https google.com. Gonna copy everything just to make sure, just so that I can modify it easier in the future. If I'm wrong, I'm gonna hit enter. And perfect, as you can see, I actually got redirected to Google, which means that we discovered an open redirect vulnerability in this page. And also, as we learned before, the fact that we see a href in here gives us a good hint that this value that is coming in here is being executed as a href link. And we know in the href, we can actually execute JavaScript by simply typing JavaScript followed by the code that we want to execute. And in our case, it's alert, let's say 4, hit enter. And perfect, as you can see, our code is getting executed on the page, which means that we discovered a reflected XSS vulnerability. So now we have two vulnerabilities discovered in this page, and both of these vulnerabilities are within elements that we would never see in normal usage of the page, and we were only able to see them by viewing hidden elements using this extension right here, and then analyzing the JavaScript code. And also a very important take-home lesson from this is that you should not worry about the code. Even if you don't know that programming language, you can always just follow it step by step and look up whatever functions or methods that you do not understand and learn that way. This is a very important trait that really good bug hunters have. A lot of the time they approach systems and code bases and applications and frameworks that they do not understand. So they might discover a hint that there is a bug, and then they discover that they don't really know how this system works or how this framework works. And they actually go ahead and learn about the framework and read the documentation and see if that can help them understand the target application. And then they go ahead and apply what they learned in order to discover their bugs and vulnerabilities. That's why a lot of bug hunters are referred to as researchers, because there is a lot of research involved when it comes to bug hunting. So now that you know how to find valid bug bounty programs that are legal to test and how to actually go ahead and test these programs, because that's what we covered in the whole course, let's assume that you actually managed to discover a bug and you want to go ahead and submit a report for that bug. Now, before you go ahead and think about submitting the report, there is a few things that you need to make sure that you have satisfied. First of all, you want to make sure that the vulnerability is valid. Sometimes people discover bugs, or not even vulnerabilities, they will be bugs that are actually part of the execution of the program, or they're not actual bugs. So you want to make sure that what you discovered is valid, because there is nothing more embarrassing than sending a report thinking that you discovered something and it's actually not a real valid bug. It's just a misunderstanding from your side. The next thing that you want to make sure is that you want to make sure that the vulnerability is in scope. And I mentioned that a few times in the previous lecture, but this is very, very important. Because like I said, first of all, it's illegal to test things that are outside of the scope. Second, you're going to be wasting your time testing stuff outside of the scope. And third, you will never get a bounty for it. Sometimes you would, but in most cases you will not. You will just piss off the people that are managing the bug bounty program. So once you make sure that you discovered an actual bug or vulnerability that is within scope, you want to go ahead to the program that you discovered the bug in. So we're assuming you discovered it in this program, ZSVPN, and you're going to have to click on Submit Report. Now, obviously, you're going to have to be signed in to be able to do this. And once you do this, you can see the process is simple enough. So you have your name, you have your email, and you have a paragraph in here where you're supposed to detail your discovery. Now, this could be slightly different depending on the program as well. When you click on Submit, you will actually see information in here telling you exactly what they want, and you will be simply filling in the blank. Other programs, you might simply just have a blank right here and you have to fill it your way. But it's very important to remember that once you submit this, whatever report I have, once I submit it, it's going to have to go through a review process where somebody is going to have to read it. They will have to manually validate whatever that you wrote in here. If they cannot reproduce whatever you did, they will get back to you, ask you questions, and you'll have to provide answers. And then they go ahead and perform more tests trying to replicate what you're saying. And all of that results into you waiting for longer for your bug to be validated and for you to get your bounty. That's why it is very important to actually provide as much details as possible so that whenever they read the report for the first time, they will fully understand what you mean and they will be able to reproduce your bug without having to ask you any questions, and therefore you will get your bounty much quicker. So you want to provide as much details as possible, you want to provide screenshots, and I actually prefer and love to provide videos. And I know from our own team that they love to see videos because once we see a video, we can see everything we want. So it's even better than screenshots because we can see all of the requests, we can see the full process that you're going through, and we can easily see whether the bug that you are submitting is valid or not, and whether it is in scope or not. And that's why we will be able to respond to you very quickly, and hopefully you will be able to get your bounty much quicker. So even like I said, there are some programs that will give you notes in here and just telling you to fill the blank into what they're asking for. I would still, at the end of all of that, provide more details if I felt like there is more details needed. And I would always provide a video because that, like I said, increases the chances of them fully understanding what I'm saying and giving me my bounty as quickly as possible. We're just going to write whatever in here. We're just going to say test. I just want to show you what this is going to look like. We're going to say that we're not a robot. We're going to agree to the terms and submit the bounty or the report. And as you can see, you're going to get more information on how this process is going to go. So your report is going to be manually reviewed, and that's why we said you want to provide as much information as possible. If it's valid, it's going to change to waiting payment. So that means that the team agreed that you discovered a valid bug, and right now you're in the process of receiving your payment. Once the payment is received from the company, it will transfer to you, and the status of the submission is going to change to paid, and then the company is going to be able to see your report. So during all of these steps, the company is not going to be able to see your report. We will be the only ones that will see your report, and only once the company pays the bounty, if it was a valid report, they will be able to see the report. Now you can actually go back and go to my reports in here, and you will be able to see the submission that we just submitted. We can see the date. We can see that the status right now is pending approval. And if you click on view, you'll see the content. So obviously there'll be much more if you submitted a real valid bug. And if the team did not understand the bug or the report that you sent, they will be writing a reply for you here, where you could also reply to them and add more attachments. And that's why I said, if you don't provide enough information, this could go for very long, and then you'll be waiting for your bounty for longer. That's why make sure that you provide as much information as possible. And that's it. This is really as simple as it gets. Let me quickly show you an example of submitting a report in HackerOne. So this is an example of Linktree, and we're going to click on Submit Report. And like I said, the submit report changes depending on the company. So this one might look a bit more complex than other companies because this is the way that they want it to be. So in here, they're asking you for the asset, the domain that you discovered the bug in. So let's just click the first one, assuming we discovered a bug in here. And then the next thing that it's going to ask you what type of a weakness it is. So let's say it is an XSS vulnerability. And then it's asking you to give it a rating. It's optional because they will be modifying this once they get the response. So you can leave this or you can set it if you want. And then you're going to get to the part that we were talking about. So you want to give it a title. We're going to say XSS, for example, you discovered a reflected XSS or whatever. Again, always provide as much information as possible, give meaningful names, even the title, make sure it is meaningful. All of this makes it easier to review your report, which will result into you getting your bounty quicker. And then in here, you can see that they are actually telling you what they want. So they're kind of making it seem like it's a fill the blank kind of thing. So you have to give them the steps in here. They're asking for the attachments in here. And then you want to write the impact in here as well. What were you able to do with that vulnerability? Now, there is programs where this could be much longer, where you will have to write so much more than what they're asking in here. So this is kind of just the basic stuff that you would get asked for anyway. You would have provided this anyway. But like I said, even if they are not asking for a lot of information, make sure you put a video and make sure you put screenshots and provide as much information as possible. If you scroll down, again, there's some optional stuff, how long it took you to discover it. It's not really that important. And then in many other cases, for example, if you look at the PayPal program, there's much more information that you will be asked for, but nothing out of the ordinary. If you manage to discover a bug in that platform, then you are familiar enough with it and you will be able to fill up that information based on the bug that you discovered. So again, do not get intimidated by HackerOne. It's a much bigger platform. I would highly recommend starting with smaller platforms like Bug Bounty and other smaller ones, and then build up your skills, build up your confidence, and move on to bigger Bug Bounty platforms or bigger Bug Bounty programs. But at the same time, there is no harm into signing up to all of these platforms because, like I said, the more platforms you sign up for, the more programs that you have. Therefore, you have more platforms to test, and therefore, your chances of discovering bugs and getting bounties are much higher.